Hello everyone, welcome to my channel. In this video, I will explain about Gaussian Mixture Models. So first we will see the definition. Gaussian Mixture Model is an unsupervised machine learning algorithm. It is used for clustering. Okay, so what is the use of this Gaussian Mixture Model? It is used for clustering. Please remember all of you, Gaussian Mixture Model is a unsupervised machine learning algorithm. Okay, so what is the meaning of unsupervised machine learning algorithm? It does not use the labels. When I say supervised learning, we are using labels. When we say unsupervised, it does not use the labels. Okay, so we'll see in this the data is grouped into clusters and then each cluster follows a normal distribution. So what is the meaning of this Gaussian mixture model? It is an unsupervised machine learning algorithm. It is used for clustering. In this, the data is grouped into clusters. Okay, so whatever data we have, the data could be grouped as clusters. So cluster means we are going to divide the data into different groups. Okay, so each cluster follows a normal distribution. So this is called as what we say Gaussian mixture model. Now you see here, unlike K-Means clustering, GMM performs soft clustering, that is each data point can belong to multiple clusters with different probabilities. Okay, so in this Gaussian mixture model, it performs the soft clustering. Note down all of you, each data point can belong to multiple clusters with different probabilities. Okay, so remember, we'll have Gaussian distribution by two parameters. Mainly there are two parameters which we talk about the Gaussian distribution. So first one is called as mu and second one is called as a variance. Actually these two are very important. That's why we mentioned in the definition, it is defined by two parameters. Okay, so first one is the mean and second one is the variance. So this is a symbol for mean and it is a symbol for variance. So this is called as mu, it is called as variance. So what is the meaning of mean? Mean nothing but center of the cluster. So center of the cluster we can say this is called as mean. So what is the meaning of variance? It is the spread of the cluster. So actually in addition to these two we have one more parameter that is called as mixing coefficient. So which we can represent it by pi. Okay, so this is called as probability of selecting that cluster. So majorly we have main two parameters are there. First one is the mean, second one is the variance. So apart from mean and variance, so there is a one more parameter is there. That parameter is called as mixing coefficient. So please remember all of you, it is one of the most important formula for Gaussian mixture models. So that is the mathematical representation. So this is called as a mathematical representation. So what is this representation? In this we have P of x is equal to, you observe, P of x is equal to, this is equal to sigma of k equal to 1 to k pi k n x by mu k comma sigma k. So this is a formula to represent Gaussian mixture models. So you need to write this formula in the exam. So what is the meaning of k here? K is called as a number of clusters and what is pi k? So this pi k is mixing coefficient and what is mu k? This mu k. So mu k is mean and sigma k is, yes, this sigma k is the covariance matrix and finally this n of x by mu comma sigma is Gaussian distribution. It is the one of the most important formula in Gaussian models. Okay, so whenever we have Gaussian models, we have one algorithm. The algorithm name is called as Expectation-Maximization algorithm. So GMM are estimated. So Gaussian models are estimated using expectation maximization algorithm. Okay, so this Gaussian models, so this Gaussian mixture models are estimated using expectation maximization algorithm. So in short we can say EMA. So what is this expectation maximization algorithm? So in this there are completely 4 steps are there. First one is called as initialization, second one is called as expectation step, and third one is called as maximization step, fourth one is called as a repeat. So what is the meaning of initialization? Choose the initial values, okay, of mean, variance and weights. Second one is the expectation step. So in short we say this is as E step. So it is used to calculate the probability. So third one is the maximization step. So we can say this is also M step. So after completion of calculating the probability, we need to update the mean and variance using calculated probability. So by taking the probability, we will calculate this will update the mean and variance and weights. Okay, so repeat these steps until model becomes stable. So you need to follow all these steps until the model become stable. So now let us see one example for this Gaussian mixture model. You can observe on the screen there is a data set is there. Let us contain number of marks on the screen you can observe. So these are different marks for different students. So the marks could be something like first one is the 45, second one is the 48, 50 and so on 90. So what is the major purpose of this Gaussian mixture model? We are going to divide the data into clusters. I would like to divide this data into 2 clusters. Then what is going to be happen? I would like to say the first cluster could be, I want to assume the first cluster could be something like around 50 and cluster 2 could be something like around 85. So whenever you have some data on the screen, so I would like to divide this data into clusters. So first one is cluster 1 and second one is cluster 2. So when you see here, I am going to have from here I selected the first value as 50. So remember all of you, what is the meaning of around 50? So the value could be it may have 50s and less than 50. When I say 85, the values could be greater than 59. This is something like from 60 to all. Okay, so now what is going to be happen? The data given as here this one. So we are going to divide the data into 2 clusters. So we want to divide the data into 2 clusters. So what is going to be happen? In the cluster 1, the average students, and the cluster 2 average students. So when you have cluster 1, okay, so here the marks near 50. So here this is a cluster 1 data, it is a cluster 2 data. Why we receive this data as cluster 1? Because here we are saying like the marks near 50. So you observe all the marks till 50 here. This is called as cluster 1. But if you see here the marks near 85, this is called as cluster 2. Okay, now what will be happen? How to find out the mean? So in this the mean nothing but middle value. So what is the middle value out of this one? This 50 is called as mean. This 85 is called as mean. So this is a way to divide the data into clusters. So you can observe cleanly now. So what is going to be happen? We have taken the data called as this one. So the data is 45, 48 and so on. The last one is 80. So from here the data is called as cluster 1. Okay, after 80 till 90 the data could be called as cluster 2. Okay, so here we have divided the data into 2 groups. So first group is cluster 1 and second one is cluster 2. and initial value is 45 in the cluster 1, last value is 55 in the cluster 1. In the cluster 2, the initial value is 80, last value is 90. So here the middle value is 50 mean, and the 85 is the cluster 2. So this is a way to divide the data in Gaussian mixture models. Each curve represents the Gaussian distribution. Okay, now let us see the uses of the Gaussian mixture models. So where we will use this model? First one is the clustering, second one is the anomaly detection, and third one is the image segmentation, and fourth one is the density estimation. So when you see clustering, we can use something like in marketing as well as medicine. When I say anomaly detection, this is nothing but fraud detection. Okay, so third one is the image segmentation, and fourth one is the density estimation. So you can observe also advantages. So what is the advantage of this Gaussian mixture models? So it supports the soft clustering, and it is also flexible. It handles overlapping. Okay, so soft clustering, flexible, overlapping. So what are the limitations? So limitations are, it is sensitive to initialization. So this is the Gaussian mixture model. Second one is the computationally it is expensive. So it is very expensive. And last one is the need to specify the number of clusters. Okay, so in the above data we mentioned as number of clusters are 2. So it is compulsory that we must specify the number of clusters. So this is all about the Gaussian mixture models. Okay, so thank you for watching this video. Please subscribe my channel. Thank you one and all.